All right. Well, happy Monday, and welcome to class. And let's take a look. Okay. So this week we'll cover. I will start introducing classes and object-oriented programming, which is, in my opinion, pretty fun. Or exciting. It's Python. In my opinion, Python does object-oriented programming like really well. Like this is I think one of the coolest things that Python does as far as handling classes and things like that. And to be honest, I don't know how often you will be creating your own classes, but when you do, there's just a bunch of nice little features that Python does. Okay, so assuming things continue well and campus operations are back to normal, we'll have class obviously in person today, in person Wednesday, and then Wednesday evening is when I travel to Python conference, which I'm excited about. So Friday's lecture will be pre-recorded, and Monday of next week will also be pre-recorded. I don't know. Should I try to live stream from the? Yes. Well, we'll see. I don't know if they'll be happy about that. So, but I do. One cool thing about Python conferences, they do release all of the video recordings at a later date. So if I attend a session that was great, I'll say hey, you guys should check this one out. And usually it's available for free on their YouTube channel. So, but anyway, okay, let's take a look at.
Vlog.
Huh?
Vlog and post it to your channel.
Do you want me to do some video vlogs? I've never done one. It's gonna be so yeah. What do I call it? What's up, YouTube? Welcome back to my channel. This is what's my name? Smiles Chen. Smiles Chen, right here. Your source for all. Okay. Why do all YouTubers talk the same way? I don't know. It's okay, but all right. Okay. So let's talk about object-oriented stuff. So in Python you have your kind of built-in types, like your lists and your tuples and dictionaries, and they all have their methods, and we've seen a lot of the methods and attributes and things like that, and they're pretty great. You can start creating your own classes, okay? And it's really easy. You just use the keyword class, and then you type in the name of the class. And actually, you don't have to put anything beyond that. If you put nothing in there, then it will complain. So if you can just put in what's called a doc string, which just if you ask for help on this class after you've defined it, it will pull up what they call the doc string. Okay. Anyway, these examples are coming straight from our textbook, Think Python. They're pretty good examples. So thank you to our author for giving us these things. And the idea here is he wants to create an object that's going to represent basically a coordinate in two-dimensional space. And so we often think of that, Cartesian coordinate system will go X and Y. Okay, so we'll do X and Y. But obviously, there's other coordinate systems. You have polar and I don't know. But yeah, those are your basic ways to represent a location in two-dimensional space. So okay. So anyway, you could store them separately as two separate variables, X and Y. You can store the coordinates as an element, in a tuple or a list. And then what we're going to do here is we're going to create a new class, and this class we're going to call point. By convention, you capitalize your class. So I mean, this is not a requirement, but here we do a class capital P point, and that's a convention to kind of distinguish like what like a new class looks like. Okay, so I'm going to just hit Shift Enter, Shift Return to run that, and there you go. It has defined a new class called point, and if you ask what is point, okay, what is this thing that I just defined? It's going to say, hey, this is a class, and it's a new class that exists in double under main. Double under main. Okay, sorry. So this is double underscore main underscore. And anytime you Python kind of reserves these double underscore things for, I don't know, I guess special meanings. And so you'll say like double under main or dunder main is often how we refer to these things. Okay, so it's this exists in kind of the global environment, which is also known as dunder main, and so so that's what you have. Okay, and the class object. Okay, so the definition of the class object, capital P point, becomes like a factory for creating point class objects. Okay, so you call point almost like it's a function. You call point parentheses, and this will create an instance of the point class object, right? So you think of this, you think of it as a factory, and you go to the factory, hey, give me whatever object this factory produces, okay? So this factory produces point objects, and we say make a point object, and I'm going to store that as blank, and so blank is now going to be, if you ask what is blank, it is a instance of the point object located at this location in memory, okay? So the distinction here is up here, when I say what is point, that is a class, basically the factory. And then at box 4, when I say what is blank, this is going to be an object of that class. Okay. Now, right now, my class has really like no defining attributes. It is just class point, and there's nothing, nothing about it, right? But now I have this point object. Right now, the instance of it is called blank, and you can start creating attributes. Okay, and you can just throw things in there, and this, you can do it in an ad hoc manner. Like you don't have to. Here we can just do blank.x, and this is going to create a new attribute called x inside this point object. All right, and so we will assign it the value 3.0, and then we're going to do blank.y, and we'll assign that the value 4.0, and that's that. Okay, and so these attributes are now created, right? So you can start giving this thing attributes, and you know, as one might expect, when we ask for it back, and I say, hey, what is blank.y? It's going to say, oh yeah, that was 4.0. Okay. Now you can create a separate thing called x, and that's completely unrelated to the value blank.x. So here I can take blank.x and assign it to object x. Okay, but these are separate, right? So x has the value 3.0. I can change blank.x to 5.0. Okay, and that's unrelated to this x. Okay, so when I assign blank.x to x up here in box 7, it's just taking the value of blank.x and assigning it to the object x, and it's not, this x is not a reference to this object blank.x here. Okay. Well, actually, no, I guess that's not true. Well, if it's a mutable thing, like if blank.x is a list, then it will be a reference, okay? But here, blank.x is a float, and individual float values are immutable, so you can't just modify that to something else. Okay, you can use that dot notation as part of any expression, and so here, you can take a string with curly braces as placeholders, and you can take the string and use the dot format method. And here we're going to take blank x and throw it into these things, and so this will print out our coordinate 5, 4 now that I've changed blank.x to 5. Okay. And so here we're going to create a function. This is going to be print point, okay? And print point will take in a point class object, p. It doesn't, there's nothing about this definition of print that says this has to be a point class object, but in my mind, this is how we're going to use the function, okay? And so we're expecting p to have attribute.x and p to have attribute.y. And then we're going to use that, put that into the format, and then we'll print it. And then so now if I do print point on this point object, I get the value 5, 4. Okay, so let's keep going. Let's create another class. This is going to be a class called rectangle. Okay, now, how do we want to define the existence of a rectangle in two-dimensional space, right? And so if you think about how to do it, there's a few ways to define a rectangle. One is you could specify 2 opposing corners and say, okay, that's going to define a rectangle. And then another is you specify, 1 corner or maybe the center of the rectangle, and then you specify the width and the height. Okay, so what we'll do is we'll, arbitrarily we'll just pick that first definition where we specify a corner, and then we're going to specify the width and the height. And I think we're going to pick the lower left-hand corner, and then we will go width and height. Okay, so again, here we're going to just define class rectangle. Right now, our class rectangle has no real meaning. It just has a docstring, but that's fine, okay? And we're going to say it needs to have 3 attributes, a width, a height, and a corner. So in this code chunk, or box here, I'm going to create an instance of a rectangle. So I'm going to do capital R rectangle parentheses to say create an instance of the rectangle, and then we're going to have box.width, box.height, and we'll assign the values 100 and 200 there. And then the corner is going to be a location in XY space, and so that will be a point class object. Box.corner will be a point, and then that corner will have an X and Y coordinate, and we'll set it to be the origin at 0, 0. Okay. All right, so that defines our rectangle there. And then so here we're going to just create a new function. This function is going to say find the center of our rectangle. The center of our rectangle is going to be a point, and the way we're going to find that is we will take the corner, which is currently our lower left corner, and then we will add the half of the width and add half of the height, and that will give us the center of our rectangle. And so here we're going to define P as a point class object, and then we're going to assign P.x and P.y, and then we will return P. Okay, so let's so right now I can ask, hey, what is box? Box is just this thing. I can ask what is box.corner. Box.corner is right, so I have to kind of get at these things one at a time. But here I can say, all right, what is what is the center here? And so center is this point object, but I can use this kind of print point center, and that will give me the coordinates, right? So print point center, center is located at 50, 100. Okay, the objects themselves are mutable. So here, I'm going to say my width is 100, okay? And then I'm going to just kind of change those values. I'm going to say box.width, I'm going to add 50 to that, and box.height is, I'm going to add 100 to that. So my box width used to be 100, now my box width is updated to 150, okay? And then, and so here you can also create functions that will modify the objects, okay? So, so here's this function that says grow rectangle, and it's going to take into its arguments will be rect, which we assume to be a rectangle class object. Okay, again, there's no, right now, the way we define this function, there's no check to make sure that it's a rectangle class object. We're just assuming and hoping that whenever somebody uses this function, they're going to put in a rectangle class object. Now, you can check to, there are functions that allow you to check to see, hey, does my object, does it belong to a certain class, or does it inherit from a certain class? And you can do that. Right now, we don't have that, okay? Right now, it's just saying, hey, we're hoping you're going to give us a rectangle class object. We're hoping you're going to give us some numeric value for d width, for delta width, and d height for delta height. And then we're going to grow our rectangle by basically adding delta width and assigning it back to rectangle, okay? So right now, my box width and box height are 150 and 300. And I could say, hey, grow the box by 50 and 100. And then when we do that, when you run this, it doesn't look like anything happened, okay? But when I check now, box width and box height is now 200 and 400, okay? So, so functions like grow rectangle, they are a little bit, I don't know, dangerous in that, like, you don't get feedback that this change has happened, right? A lot of times when you run a function, we expect it to kind of output something to let us know, hey, something happened. And this, like, it runs and it made a change, but it doesn't tell us, like, hey, just so you know, this is what happened. So, you know, if I were to like run this again, like now my box width and box height would grow even further, right? Okay. All right, let's try a couple things here. All right, so here, let's create a new point, P1, okay? P1, I'm gonna assign X and Y to be 3 and 4, and then I'm gonna create a copy, okay? And so here, I'm gonna import the module copy, and we're gonna create a copy of P1, and we're gonna call that P2, okay? So I can say, hey, what is P1? P1 is 3, 4. P2 is 3, 4, okay? Now, when you ask, is something equal to the other, it's gonna basically, well, this is a check for equality, which we don't have currently defined for point class objects. So it's just gonna say check to see if it's the same. And it's gonna recognize that those are not the same object, right? So it's kind of like, I don't know, you have 2 copies of the same thing. They are not the same, right? I've got this battery and I've got this battery, and these are like, they're like duplicates of the same thing, but they're not the same object, right? Whereas, like, if somehow I were just decided to name this battery, and you know, this is now my friend Joe, okay, and somehow you gave it a different name, right? Joseph, okay, and we can say, hey, is Joe and Joseph the same thing? Yes, all right, but these are different, right? So this is John over here, right? They're different. They are both batteries and something like that, but they're not the same, okay? And so you can ask, the full name of P1. Okay, point 1 is it's a point located at this location in memory. This is the kind of the memory address, right? And you can see this thing, slightly different address in memory. Okay, FD D8EC990, and then this is FD8CB0D0. Okay, I mean, sure, but that's where you're going to find this this thing here. Okay. All right. So I think we talked about shallow copies and deep copies earlier, but it also makes a difference when you have objects and objects within other objects and things like that. Okay. So here is I've got a box, and right now box has a corner. Okay. And it's a point located here, and we can ask, hey, what is the location of the box corner, right? Box corner is at 0, 0. Okay, I'm going to create a copy of this box. Okay, we're going to call this box 2. We can ask, is box 2 the same as box? And the answer is no. Okay, but remember, box contains a point object that we've called corner. Okay. And then so box 2 creates a copy of all of those things. It creates a copy of box width and box height and a copy of box corner. In box 2, the copy of that corner is a reference to the corner in box. Okay? And so so we can ask, is the corner in box 2 the same as the corner in box? And the answer there is true. Okay, I'm trying to think how this works. I mean, like what a good analogy is, right? So box 2, we can ask, what's the corner here? And it's this thing. And then what's the corner here? And it's also it's the exact same object at the exact same memory address. So box 2 and box are different, but they both contain references to corner. And that corner is the same for both, okay? I guess it would be like, I don't know, somebody creates a fan fiction of some, referencing some popular franchise, okay? I don't know, you decide to write some Star Wars fan fiction, okay? And somebody else creates another fan fiction that has like very similar plot lines or something, right? And you can say, oh, one's a copy of the other. But as far as like when they reference like events in the past, okay, they're all referencing the same kind of canon of like the actual things, despite, now you have these diverging storylines of, I don't know. Maybe that's a ridiculous example. I mean, any example that uses fan fiction as an example is probably ridiculous, but we know what that is, right? Or is that like, am I talking gibberish here because I've ventured into corners of the internet that...
Like P1 and P2, they are the reason why P1 and P2 are different because like they are different references. However, the reason why like P1.corner or P2.corner are the same because they all reference to the same block, like the same content.
They're referencing the same object. I don't know. They're referencing like the same instance of the object. So, I have this battery, and when we talk about the battery, it's this one. Okay, and when you created a copy, you didn't get your own separate battery. You're still counting on this one thing. Okay. Yeah, it's it's a little bit weird because on the computer it's really easy to duplicate things, okay, and make copies, whereas in like real life to kind of create a copy and a duplicate, it's a little bit harder, and you end up like in real life when you create a copy of something, you generally create what in computer land we would call a deep copy, okay? So that's what we have. So here, if I modify the corner of box corner dot x, if I change that to 1, box corner x is 1. And because box 2's corner is the same exact object, when that thing gets its corner, I mean, it's the same thing. So box 2 corner is x is also 1, okay? Because it's the same object, right? So if we're talking about the same person and that person decided to change their hair color, like, it's the same person when we're talking about, you know, Joe. Okay. But, you know, box 1 and box 2 are separate, so they do have separate height attributes. So box's height is 400 and box 2's height currently is 400. I can change box height to 200, and that will change it to 200, but box 2 is separate from box, so its height attribute is separate. So box 2 height remains 400, whereas box height is 200, right? If you want the embedded objects to be copies themselves, you can create a deep copy, okay? And then a deep copy, you know, box 3 is box, and then box 3's corner is no longer the same as box corner, right? So box 3 is a deep copy of box. It gets its own new height and width attributes, and then it gets a duplicate of the box corner, but it's a separate object, you know, okay? So the is operator kind of checks to see, is that object the same same as the other thing, you know, as far as kind of like the memory address location. All right, let me give you your first view quiz answer, which is the letter C. C as in cat. C as in cat. Okay, all right, let's do another example here. We're going to create a time class object. Now, Python already has a way to keep track of time and stuff, but we will create our own time class object, and so we will have 3 attributes. And again, right now, our current definitions of classes currently are completely useless, but here we're going to add stuff. So here we're going to say, hey, we've got an hour and a minute and a second attribute, okay? So we're going to do 11:59 and 30 seconds. And then we're going to create a function called print time, and this will just create a string with 2 digits, colon, 2 digits, colon, 2 digits, because for whatever reason, that's how we are accustomed to seeing time. And so when we say, hey, print time, and take in, you know, the hour, minute, second, and print that out, you know, we get 11:59:30, and this is what we have. Okay. Okay, we are. I'm going to create a couple more functions here, and this, I guess, points at kind of the 2 different types of functions that you can create. You can create pure functions, which is basically how all of R works. All of R is almost entirely pure functions in that arguments come in, the function returns an object, okay, or a value or something, and the arguments that came in don't ever get modified by the function. So that's a pure function. Something comes in, it spits something out as output, but the things that come in don't get modified by the function itself, okay? But then you also have modifiers. Modifiers will, you know, you have arguments coming in, and then it modifies the arguments coming in, okay? There's also a couple development approaches as far as like writing a function, and so so our author talks about kind of prototype and patch, and also, you know, just this whole, you know, planning from the beginning, okay? So prototype and patch is this idea of like you start off with a very basic version of what you're trying to do, and then once you get that working, you find out like where it breaks or where it doesn't quite work or where it doesn't do what you want it to do yet, and then you add extra lines of code to kind of expand on it so it it no longer breaks, okay? So we'll take that approach, and basically here we're going to just take, we're going to create a function called add time. It's going to take two time objects, t1 and t2, and then it's going to return what happens when you add these two bits of time together, okay? So here we will do t1 and t2. We're going to return a new time class object called sum, and for sum right now we're just going to take the time 1's hour and time 2 hour. We'll take time 1 minute and time 2 minute and time 1 second and time 2 second. We'll add them together, and then and that will be sum hour, sum dot minute, sum dot second, and we will return the sum. Okay, so if I say I've got the start time is 9:45 and then the duration is 1:35, I can say, hey, let's add these two together, and we get 1080, right? And then we go, oh, you know what, that's not a time because we're on a 60-minute clock, which is interesting. Like why we have a 60-minute clock? Is there a history there? Is it something with like the Babylonians because they like the number 60? Base 60, right? Because like
also has 360.
Yeah, 360 in a circle. Because it's like what 2 times 3 times like 2, 3, 4, 5, 6, 10 are all like they go into 60. I don't know, whatever, 12. But is it, yeah, this we cannot agree on language like universally, but somehow the whole world is like, all right, 60 seconds in an hour, let's do it, okay? Until we colonize Mars, and then you're going to have Mars times and Martian souls, and I don't know what that's going to be like, but anyway, all right. Sorry, tangent. Okay, so what we need to do now is we got to say, okay, well, if the number of seconds is over 60, subtract 60, and then add 1 to the number of minutes, and then if the number of minutes go over 60, subtract 60 from the minutes and add 1 to the hour, okay? And we go, okay, well, that should work. And then you want to do the seconds before you do the minutes, right? Because if you did the minutes first and then you did the seconds, it's possible that you then like rolled over the minutes and then you have to redo the minutes calculation. So do this. So now we do this and we go, oh, okay, yeah, now it works, right? 9:45 plus 1:35 takes us to 11:20. Okay, so that seems to work right now. Another way is we could just say, hey, you know what? What if we took our time and we incremented it by the number of seconds, okay? So, so this is going to be a modifier function. This one you don't see a return statement here, okay? So this function isn't going to return anything, but what you can see what it does is it takes in this time class object and then it modifies the object that came in, okay? So you could see that the attributes of time get modified, right? So first it's going to just take time.seconds. We're going to add whatever the number of seconds is, and then if the number of seconds go over 60, then we'll subtract 60, increment the minutes. If the minutes go over 60, we'll subtract 60 and add 1 to the hour. Okay, so we try this and we say, okay, here's 9:45. Let's increment it by 90 seconds, and that takes us to 9:46 and 30 seconds. Okay, what if I want to increment it 185 seconds? Okay, this doesn't work anymore. Okay, so we go, oh, okay, so now I gotta fix this even further, right? So so we realize, oh yeah, here basically I just check to see if it goes over 60, and if it goes over 60 I just subtract 60. But if I added something like 200, subtracting 60 is not going to be enough. So what I have to do is I have to take the total number of seconds, and I'm going to do remainder division, right? So I'm going to say, all right, if you're going to give me 200 seconds, I'm going to divide by 60, and I'm going to get 3 minutes remainder 20, okay? So then I'm going to say, okay, 200 seconds is going to be 3 remainder 2, or I guess 185 will be 3 minutes 5 seconds, so we'll get 3, 5. And then if that number of minutes happens to be over 60 as well, we will div mod that, right? So if I said like 3,650 seconds or something, okay, then I have to do div mod with the minutes. We'll get hours and seconds. And I guess you could keep going and you could do div mod hours to like 24 hours in a day and so on and so forth. Okay, but right now we're not going to worry about that. Okay, so we got, so we'll take that, and then once we get the proper number of seconds, we know that is not going to be over, that this number of seconds is not going to be over 60, so we'll add that. We'll add the minutes, we'll add the hours, and then now time.second could still be over 60, right? Because right now time.second could be 59, and we add 59 seconds to it, so that goes over, that's going to be over 60, but we know it's not going to be over 120, so I could subtract off one instance of 60. Same thing with the minutes. I know it's not going to go over 120, so I subtract off that. Okay, so now we've patched up our thing. We'll try it out. 9:45, add 185 seconds. Okay, now it's working. That takes us to 9:48 and 5 seconds. Okay, let's try adding 4,800 seconds, which is equivalent to 1 hour and 20 minutes. And yeah, that works. Okay, that takes us to 11:08 and 5 seconds. Okay, so these are all, but notice these are modifiers. So the increment function itself modified the test time, and in order for me to see that it did modify test time, I also had to call print test time to make sure. Oh man, I am, it's already 9:40. Okay, second answer is B. B as in bear. B as in bear. Okay, what did I say? All right, so anything that can be done with a modifier can also be done with a pure function. Modifiers are convenient, but can also become difficult to debug. These are all true statements. And in contrast to Python, most of R only allows for pure functions, with the exception of reference classes in R6 and things like that. Another approach, so what we've been doing is this prototype and patch. We wrote something. Sorry, I shouldn't be laughing at your. And then the other is design development, where you kind of plan this thing from the start. And so you say, okay, well, what's another way for us to think about this? Okay, so we're going to take a time, turn it into seconds. The idea here is if you wanted to add 2 times, instead of saying like, okay, let's add the hours and let's add the minutes and let's add the seconds, which is the way us humans think about stuff, but you say, well, you know what, the computer's really good at adding big numbers and not having any trouble with it. So another way to think about it is you just say, all right, take 9:45, turn that into seconds from after midnight, okay? Take another thing, turn it into seconds after midnight. Add the 2 things of seconds together, and then figure out how many hours and minutes that is, okay? So we're gonna do time to integers. We'll take, the minutes will be the number of hours times 60, and then the number of seconds will be all the minutes times 60 plus the number of seconds, okay? And then once you have that, integer to time is whatever time you have, you'll take the number of seconds, okay? I'm sorry, whatever number of seconds you have, you'll div mod that to get minutes and seconds, and then however many minutes you have, you'll div mod that to get your number of hours and minutes. Okay, so here, my test time will be 9:45. Let's make that number of seconds. That's 35,100 seconds. And then, can we convert 35,100 seconds back to time? Yep, it turns that back into 9:45. Okay? And so now look how simple our add time has become. We do time 1, time 2. We just turn those into integers. Time to int t1, time to int t2. And then we add those 2 together. And then we will integer to time the total number of seconds. Okay? And that's going to make it easy. Okay? So, I mean, I could try this out. So I could do, what is t1? Oh, no, I haven't defined T1. It was start, or is it? I got test time and duration. Okay, I got start. All right, So let's do print time start and print time duration, okay? And then, okay, so I can now add time. So wait, add time is this this function, and I can do add time start and duration. And this is going to give me this thing, so we'll ask it to print time. Why am I having a hard time with this? All right. And it seems to be working. It seems to be working here, okay? So add time just kind of converts our things into integers and then adds them together and converts that total back into some kind of time here. Okay, so finally, let's start developing our time class object, and we will start giving it like methods and things, right? So methods are functions, okay, that are associated with a particular class. And so methods are basically the same thing as a function. They are functions, okay, except they are defined inside the class definition, okay? So inside the class definition, that's where the definition of the method is. And then when you invoke a method, you're going to use like dot notation, okay? It shows up as kind of like an attribute. Okay, so right now my class time is still this useless nothing definition, okay? And right now, let's just kind of revisit what we've done is we created this print time object, okay? And so here we can say, all right, this is how we've done things so far. Is we say start is going to be an instance of time, and then we define the hour, minute, second, and then I call print time here, okay? So all I'm going to do, okay, all I'm going to do is I'm going to just copy this definition of print time and move it into my class definition, okay? So now I'm going to have class time, and we're going to define this method. So all I did was it basically just copied and pasted this inside my class definition, okay? So now that I class time here, I can define a new instance of the time class object, okay? So every time you create a new definition of your class, you got to create new instances of that thing, right? So I've redefined what it means to be time. It sounds much more philosophical than it is, but we redefined what a time class object is, and so now I have to create a new instance of this thing, okay? So here is start.hour is 9, start.minute is 45, start.second is 0, and now I can call the method. So there's a couple ways I can call this. One is I could say, using the time class definition, find the method print time and run it on the object start, okay? This is a legitimate but like almost never used way of using methods, okay? Instead, because start is a time class object, we're probably going to just call start dot print time, okay? Because start is the object that we've created, so I'm going to do start dot print time, and then it will run it for itself, and it prints out 9:45, okay? All right. So, well, actually, I think the discussion of self gets exciting, but we'll save that for Wednesday, okay? So we'll pause here. We'll end just a couple minutes early. Let me go ahead and give you oh geez, where did it go? Okay, third viewing quiz answer is the letter A. A as in apple. A as in apple is your third view quiz answer. Okay, so we will end here, and then we'll talk more about methods and self and all of this. And again, I'm excited because Python object-oriented programming, I think, is something that Python does really well. Okay, we'll end here, and we'll see you guys on Wednesday. Have a great rest of your day.
Professor, I have